Hello, and welcome to Pass the Torque. I'm your host, Katie Kadri. This week, we're hearing about all things space tools from Justin Cassidy. Justin helped develop the tools used by astronauts on the Hubble servicing missions and on ISS. Before we hear from Justin, though, we do have a special shout-out from retired astronaut Mike Massimino, or Mass. Mass and Justin have worked together in the past in developing and using these tools, so he's here to tell us a little bit about his own experiences with Justin. Take it away, Mass.
Hi, I'm Mike Massimino speaking to you from New York about astronaut tools for this episode of Pass the Torque. I've known Justin Cassidy for a long time. We met over 20 years ago, believe it or not, when I was a relatively new astronaut and he was working on the Hubble Space Telescope servicing project. We were getting ready for a mission, STS-109. I met him before I was assigned to the mission. We were working on development runs, and then I was assigned to the mission, and he prepared me for that flight. And he prepared me for another flight, STS-125, and we've been friends ever since we first met. So it's a pleasure to be on his program. How do you get ready to use tools in space? Well, Justin helped me get ready, so he can tell you what that was like. But we got ready. First, we would usually get a briefing. Someone like Justin would show us the tool we were going to use. Actually, even begin before then, we would get ready to see what kind of tools we needed, especially on our second flight. We invented a lot of new tools. We tried to help Justin and his team as best we could. So you might talk about what you need and do a prototype of it. They'll come up with something that we can try or look at a drawing, and then they'll actually fabricate something, and then we'll test it out in the pool and get familiar with it, maybe make some changes. But it was a pretty interesting development process. And the biggest difference you can imagine, one is that tools will float in space, so you always want to make sure you have it attached in some way so you don't lose it through a tether point, to a tether hook, to a piece of cord or lanyard, so you won't lose it. The feel of it is much different. You can't get the same feeling sensation that we get in our hands when we use tools on Earth. In space, you're working with a space glove, so you don't get that same feel for the tool. Also, but they try to make the tool as compatible to that, so you have a good grip, a good hand on it, a good grip on it. You have to have the handle of the tool, for example, if you're dealing with a tool with a handle, has to be a pretty large grip on it, so you don't have to bend your fingers too much with the hard pressure glove. And then also things like visibility, believe it or not, can't come into play because you can't really see that well. You have a helmet, the lighting might not be great, so they try to make up for all those things in the tool design, and Justin was an expert at that. So it's great for me to be a part of the program.
Thanks so much, Mass. And now we're ready to jump in with Justin and hear about the process of designing and testing these tools so that they're space ready. Let's start with the first question. Can you tell us about what you do in your career at NASA?
Sure. My career at NASA's been spanning over a couple of decades. My highlight of my career at NASA was being able to work on the Hubble Space Telescope for 4 out of the 5 servicing missions. So I started working that in around the mid-90s and all the way up to the last servicing mission. So overall, that was about a 15-year period. From that point on, I went on and did some work on the ISS, where our division at NASA Goddard flew a couple of payloads up onto space station for doing demonstrations for robotic satellite servicing. So over the many years, I've really focused on satellite servicing all the way from Hubble, which was human astronaut servicing, up to today, where we've been doing on-orbit robotic servicing technology development.
Can you tell us about the tool development process for astronauts and for robots?
Basically, when you have something at home that is broken, needs repair or maintenance of something at home, you call someone who's going to come help you, or if you have tools in your garage, you're going to go about that particular repair or maintenance of your home. So a lot of our tools that we create for astronauts in the space environment for any kind of work on the space station or previous example, Hubble Space Telescope, it is really task-driven in that we know we're going there, we know we're going to be doing some work, whether it's replacing an instrument, a avionics box, or repairing something that's broken that we need to get into in order to enable or facilitate the repair. So a lot of our tools that we develop aren't necessarily new technologies that we've created. It's really something we're putting things together that already exist and packaging it into a means that the astronaut can use at their work site. And a work site is basically a place where they're working, where the problem is that they're trying to solve. And the difficulties in the work site is it can be very dark, very constraining. They're working in a spacesuit. All these attributes have different aspects that when you start designing a tool, you have to add on all these requirements or basically features to that tool that we have to make the tool. So not even before we get into like, this is what the tool needs to do, there's an overarching set of high-level requirements that says, this is how you have to make a tool, and this is how you have to make it compatible to be used by an astronaut. So that across the board for all tools is basically how we start with designing tools. Now, when you start getting into the particular work site, that really starts helping you define the different aspects of what that tool needs to do. So there's a problem or there's a maintenance item that you need to fix. So you need a tool to do that. So that interface is going to be very, very specialized, and we're basically going to have to create a tool or bring a tool that is going to be able to help them open that interface or perform that repair, upgrade, or maintenance item.
How are tools tested before they are used in space? How do astronauts learn to use them?
So in addition to identifying different maintenance or repair items that we need a tool to perform, we have to go about creating that tool and then bring it to our particular astronaut and sometimes for a robot on how they're going to use that tool. And through the advancements of rapid prototyping, meaning like growing plastic or doing rapid CNC, which is metal, we're able now to create very different, many different prototypes or ideas or revisions of tools. And what we often do is we put those in the hands of astronauts. We have people that create mock-ups of the work site where we're working, and we start to perform evaluations to find out whether these tools can help them do their job, or when they're evaluating that prototype, how they can make that tool better to use for them, whether it's adding features to capture items so they don't float away, to visual aids that help them know the tools in the proper position. And even if we're going to make it a hand tool that they're going to turn a knob, or they're connected to a power tool because it's going to take a lot of turns to release something. We also leverage on different training resources at the Johnson Space Center. There's the NBL, which is the Neutral Buoyancy Lab, and also the ARCOS facility, which is the Active Response Gravity Offload System at JSC in Building 9, their training center. So the Argos system is like a shirt sleeve. It's kind of like Mission Impossible, or like a puppet. You hang the astronaut down from the ceiling, and it offloads their weight, so they're kind of floating, if you will. And they're able to perform different evaluations of repair or work or training events, and have astronauts like, experts like me, engineers and fellow people that work in the ops division support and actually follow along, and we're able to talk to them and feedback. The other resource that we use is the Neutral Buoyancy Lab, where the astronaut wears their spacesuit and they go underwater. And there are scuba divers, and I'm one of those scuba divers, that are able to dive and support that training event, evaluating tools, evaluating the work site, trying to figure out, because there is no way up really, what is the best position for them to access that work site and to evaluate the tools and get feedback. And then we would go back, we would do our homework, we would make all these updates, and then we would come back to an Argos or an NBL run, and we get into the cycle of performing what is the best and optimal tool or tools that we need in order to perform these repairs. And then we move on to our development of actually making the tool, preparing it for flight, as well as in parallel training the astronauts with these tools that they'll use for the eventual flight use.
You heard from Justin about the training process. Now let's hear from astronaut Drew Morgan, who is on the other side of the training.
Hi, I'm NASA astronaut Drew Morgan. I'm a colonel in the United States Army, and I was a member of the ISS Expedition 60, 61, and 62. I was also an EVA crew member for the AMS repair, along with my crewmate Luca Parmitano. The Alpha Magnetic Spectrometer, AMS, was never meant to be repaired in a spacewalk, and so we had to develop very specific tools for that, and that started years before the set of spacewalks. And in fact, it took almost 4 years to develop the tools and the hardware and the techniques to repair AMS. I became involved pretty late, actually, just a couple of months before launch, and our training specific to the AMS repair for Luca and I happened just in the 4 months prior to us launching in July 2019 from Baikonur Cosmodrome. So I, as a crew member, primarily in the EV2 role, was introduced to the tools fairly late in my training flow, and I actually had the opportunity to do a number of training sessions with Luca Parmitano in those couple of months prior to us launching. There are a variety of methods that we used to train and become familiar with the tools. The first thing we did, Justin and his team, exposed us in tabletop settings where we looked at the tools and we learned how they worked and their particular nuances and how to get out of failures and exactly what's the proper way to use these ingenious tools. Then the next method is we had lower fidelity tools that we used in the neutral buoyancy laboratory that we took underwater with us when we practiced for this spacewalk and went through the exact movements and techniques that we would use to get into the AMS and then access the tubes, make cuts in the tubes. It was my honor to be part of the AMS team and a successful set of EVAs to repair AMS so that it can continue its scientific legacy for the ISS for years to come.
What tool are you most proud of?
But the tools are really outstanding for what they do, and they're very unique, and their use is very limited to, they were basically made for one purpose. Some tools are pretty universal in that, but there are some different aspects of tools that really do stand out. The one that comes to my mind that had been my favorite was back in the Hubble Space Telescope repair where we were fixing the STIS instrument, that we had to remove a radiator cover that had 100 small fasteners, and they also had washers. So there's a lot of little tiny things that could get loose, and those loose things could get in front and mess up the optics of Hubble. And that's a really bad day for science if we were putting debris in the optical path of Hubble. So this faster capture plate was a system in itself, even though it was a single plate. It had a lot of features, a lot of setup, a lot of install techniques and training and whatnot. So there were a lot of tools associated with this faster capture plate, but the essence of the faster capture itself is probably one of my favorite tools that we come together. Now, when you fast forward from Hubble last servicing was about 11 years ago till this past year, we supported another instrument repair up on the International Space Station called the Alpha Magnetic Spectrometer. And basically, I was able to re-architecture, leverage, and make smaller some of these techniques and means and tools that we supported the repair of the Hubble Space Telescope instruments into a smaller architecture that would work for the AMS repair. And they worked great, they were flawless, they did exactly what we were expecting for them to do. And in some cases in the end, we ended up throwing them overboard because they had served their purpose, and our plan was to keep everything together, don't let any screws loose, just put it attached to this big item and just throw it overboard, and off it went. The other tool that I'm also quite proud of is the AMS tube cutting guide. This is something that became necessary because during the repair, the astronauts were required to cut a number of very small, 4 millimeters in diameter tubes. All the tubes look exactly alike. They were very, very small, and the crew was challenged in being able to see out of their helmet. And because it's dark, there are many, many factors that basically is very hard to determine what is the right tube that they needed to cut. So very quickly, we worked with the folks at JSC, and we came up with a tube cutting guide, which was basically a tube cutting guide that was able to be held up and attached onto the tubes that basically gave you numbers to point to, green meaning good and red being bad and black meaning indifferent, giving the crews the identification for this is the correct tube to cut. If it was green, it had a number on it. We made 2 sets of them because they were making 2 separate cuts to the, as you see in the video, to the left and to the right of the VSB tray is what it's called. So these tube cutting guides, they're kind of simple. They're kind of my favorite because it came together very, very quickly. And the folks at JSC were able to put this into their evaluation flow, both training at the ARCOS facility and the MBF facility, to try out these tube cutting guides, and they ended up being a very valuable asset for the crew to use to help them identify what is the correct tube and what is not the correct tube to cut, and eventually led to the successful repair of the AMS instrument.
How do astronaut tools and robotic tools look different?
Regarding how astronaut and robotic tools look different, they really do look different. Astronaut tools are more in the size and the shape of like a hand tool, something very small and manageable. The reason is because we've got the intelligent astronaut, the human aspect right at the work site, and their ability to use a tool locally with cognitive reasoning and basically they're there, they feel things. That is a wonderful thing. But it's also a luxury that is not always available to you. That brings in robotics. When you're building a robotic tool, you have to rely on the dexterity of the joints of that particular robot and the end effector, which is basically what you're plugging the tool into, or the socket onto the socket wrench. Robots are very slow in what they move. They're very, very capable. They're very, very strong. The tool tends to be more bulkier just because in case that arm was to run away and hit something, you don't want to make a tool that's going to break. So I think as a whole, astronaut tools are a lot smaller and lighter and maybe less complex, whereas robotic tools are heavier, robust, beefy, and stronger, yet they do have the same capability, but you're relying on an operator that's much, much further away than having an astronaut right there reasoning and rationalizing how they are conducting the repair. It's really hard to replace an astronaut, but it can be done. But there is a marriage between human and robotic servicing.
How do space tools and Earth tools look different?
The difference between a space tool and a tool you would use on Earth is, the specialty. The astronauts certainly do have hammers that they bring up to space that they could use, but we really don't often use hammers. So the tools that we make for astronauts are very, very specialized, and they don't necessarily have the applicability to use around the home. Sure, they may be screwdrivers, but the screwdrivers we make are very particular in that they need to capture a certain way and function in a certain way. So there is a difference between the two. They are similar, but I will tell you, to create an astronaut tool that they use in the vacuum of space that can get really hot and really, really cold, the things that we do in order to manage the materials and the CTE, the coefficient of thermal expansion, how those materials interact with each other. You don't want to bring up a commercial tool into outer space because it may not function, because it could seize up, because it's not meant to be used in the vacuum, cold and hot of space.
Can you tell us about your Silver Snoopy award?
I did get a Silver Snoopy, which is an award given by the NASA and by the Astronaut Corps for recognizing individuals who have helped and assist the exploration of space from the astronaut office. So it's a great award that I received about a year and a half ago. The astronaut member who gave it to me was John Grunsfeld, and he gave it to me at a Hubble celebration for Hubble's 25 years of servicing. So it was great because it was given to me in front of a very large audience with a lot of my peers. There are also other astronauts in attendance, so I got great photos, great mementos, basically, of me getting the award and posing with this great achievement that is really honored to have from working all the years on the Hubble Space Telescope, and my contribution to supporting the astronauts during all the servicing missions and the development of the tools and the different contingency and operation procedures that I helped develop to make the satellite servicing of Hubble successful.
How have tools changed and developed since you first began working on the Hubble Space Telescope servicing missions?
How have tools changed is that we really are leveraging on the capability of prototyping, the ability to create an idea in a CAD program and basically put it out to a printer and basically have that tangible product in front of you for talk around a table, to put in front of an astronaut, to use it in the workspace that you're thinking of. So that really is that chunk of how are we going to do this to a prototype is really shrunk in the ability of how quick you could turn that around. And then even in between prototypes, it's really fascinating how we have evolved in that.
What type of role do you think tools will play in the future of space exploration?
Yeah, so I've been thinking about this, how tools are going to be used in the future, the space architecture that we're going out to, whether it's Gateway, Moon, and Mars. So I think I kind of liken this into that you need a tool in order to do things. For example, you need tools to build a house. So when we go set up a habitat on the moon, I don't think we're bringing I-beams and we're recutting them and welding stuff together. That's not where we're at right now. We're basically going to be assembling modules together, whether by astronauts or by robots. So the tools that are going to be used in order to perform that basically are assembly tools. What we really specialize is in maintenance and repair of things that are not working. So again, going back to the house and putting things together on the moon is once astronauts get onto the moon, they're going to do exploration. So they're it's like they're going to the beach. They're going to need shovels. They're going to need scoops. They're going to need tools that are going to assist them doing collection of data, collection of minerals and soils, etc. So yes, those are tools, and they're very generic tools in themselves, but perhaps those tools get augmented into be smarter tools and that they have electronics and sensors associated with them. I still feel there's going to be a need that once you're set up at Gateway, Mars, and the moon in between, that you will need tools in order to sustain and maintain and repair items once things are not working. So I don't think we're just at that point of needing repair tools for those future exploration activities, but they will come. We just have not been identified with what they're going to be.
What do you do for fun outside of NASA?
So what I do outside of NASA, I really dedicate my life there. I'm home not very often, but what do I do for fun? So I mean, I do the typical. I play golf and tennis and ski and run. I'm a big swimmer. Actually, over the last couple of years, I've really been picking up on my swimming. And that has actually helped me in work in that when I swim for a long time and it's actually quite boring. I have used that time, particularly for the recent AMS repair, to use that time and think about the tools that I needed to create for the AMS repair. Also in my other hobbies, I guess, around the house, I was mentioning a handyman. So I've gotten very good at doing renovations. So that is kind of like my side hobby. I do different renovations for me and for my family, ripping out walls and redoing kitchens and bathrooms, etc. So that is a passion I like, and it's all associated with tools. So I feel I am in the right place in both home and work, working with tools and working with people who have the expertise to use those tools, particularly in space.
Thanks so much, Justin. And thank you for tuning in to our final episode of Pass the Torque. We've talked about robotics, exploration, and everything in between. We hope you had fun and learned a little bit about science, engineering, and the people here at NASA. Don't forget to follow us on Facebook and Twitter to see what we've got coming up next. Until then, thank you, and ad astra.
So as far as show and tell, I have a nice Tiffany box that is in the back of my drawer, but I did pull it out, and I got a couple of things in here that are really cool. One is a cigar, bubblegum cigar for my daughter when she was born, so that's not really spacey. But what I have here is a piece of paper, and when I open up the piece of paper, I've had this in here for years, and what it is a solar cell. This is a solar cell that was on Hubble Space Telescope on one of the solar rays that was returned back to Earth. I was fortunate that someone was able to, taking samples, basically cell sections, off of the returned solar ray, and I was a beneficiary of getting one of the solar cells. So this, I haven't been treated very well, back in my drawer, but nonetheless, I do have it, and this is something that I treasure very much. Since much of my career I worked on the Hubble Space Telescope, I put together a collection of all the mission coins. So here is that collection, and it's probably impossible to see really close, but these are all the medallions associated with the Hubble servicing, from the first one, which is the just overall Hubble Space Telescope medallion, followed by the deploy, servicing mission 1, servicing mission 2, servicing mission 3A, 3B, and then in the corner, servicing mission 4. So I don't display this enough, but it's a pretty cool keepsake to have this, and then it's in the form of a shuttle.